All right, so I've been having more fun with AI, in case you couldn't tell. This image, I asked it to create an image of the technician soldering a PC board, include a microscope and some other equipment, and so there you go.
How come she doesn't look happy?
I don't know, probably because she's in China getting paid 50 cents a day. All right, so I've got a couple of ramblings, and we're going to go into historical circuit board construction techniques. Larry's going to talk about some of his knowledge around that. Then Dave's going to come in and talk about board design and manufacturing, different ways of doing that. Then we're going to go into some modern board construction techniques, including a couple of demos. Larry brought his CNC machine, so he's actually going to demo using a CNC machine to carve out a PC board. So that's kind of cool. And then we're going to do a hand soldering and reflow SMT board cooking demo. And then you all will have a homework assignment, so make sure you pay attention to that. Okay. Before we keep, I don't know why it keeps showing up there in the corner, but anyway. As far as a couple other things, so I just discovered this like a week ago. It turns out in 1981, a couple of hams got together and they said, you know, there's this new thing called the internet, and we ought to get some a block of IP addresses, internet addresses for ham radio use. Yeah, exactly. And so they did that, and they got an entire 44 is the top level designator, like when you go to an IP address of something dot something dot something, blah, blah, blah. 44 is the high level. We have the entire subnet.
And by the way, I think it costs sort of under $100 to do that.
Well,
yeah,
they've sold off part of it.
Yeah, I'm going to talk about that. Yeah, it's cost about $100. We got 16 million IP addresses. Pretty amazing. Of course, in 1981, nobody knew, right, what the internet was going to be. Today, well, not today, but a little while ago, they sold off a quarter of those for $100 million. And they put that into a foundation called the NA0TC, Amateur Radio Digital Communications. And they use that money to give grants for all sorts of ham radio related projects for nonprofits. So yeah, it's pretty cool.
And just as one of the guys on the committee for the grant writing lives over in Smoky Hill area.
Oh, interesting.
Used to be a boss of mine years ago.
Oh, wow. Cool. Yeah, so there's all kinds of things you can do with these addresses. Basically it just gives you like a permanent address on the internet. Well, permanent until you pass on or whatever. You don't own it, right? They just lease it to you, quote unquote. But it's free, completely free. Some of the uses you could do with that would be like getting remote station access, setting up VPNs, setting up web servers, all kinds of potential uses for that. I went ahead and requested a block. I think it was a /27 block, which gives you 7 usable IP addresses. Took about 4 days, and they just granted it to me. Only it's something like 2% of all of those addresses of the 12.5 million that still exist are being used. So they would really like more hams to start using those. Otherwise, who knows? I thought this was kind of interesting. It's kind of blurry. It's off their website, but if this is the entire internet, this is the block that we own. Pretty impressive. Think about that. So yeah, if they sold off 25% for 100 million, that's quite a little Easter egg that they're sitting on there, treasure chest. There's the request I put in, I sent to them. And I just said I want to use it for my hot spots, and I gave them a little bit of description, and again, they came back and said, yep, it's yours. Okay, another thing, I've been putting this up on the club groups.io channel, but yeah, we've had, I don't know if you guys have heard about this, but if you tune your radio to 438.125, pretty much anywhere on the Front Range, you can hear this thing being broadcast. And I actually have a recording of this I'll play so you guys can hear it. But basically, it's pulsing about once a second, and about every 2 minutes, it does a long data, like a 10-second data pulse. There's no ID, and no one that I found so far has been able to identify what this signal is. I fed it into my SDR play, and I tried different decodes, and I couldn't get it to come up with anything. So there's a ham who's out in Fort Collins. His name's Greg. And he's one, and the folks out in Fort Collins were the ones that first heard this thing. So, and the transmitter's somewhere out here. So if it's making it to Fort Collins, Either they've got one heck of an antenna or they're putting out a lot of power or something, but they made a few trips out here trying to find it. And they started having issues with reflections and things. And Jim, like when you were trying to find that transmitter last year or whenever that was, you had the same kind of problem. But anyway, he approached us because he was hoping that you could find the hams that live closer, put together like basically a hunt party and try to figure out where this thing is and who owns it. And they've narrowed it down. And these poor people have made several trips. It's 140 miles round trip for them. They've made several trips out here, and they managed to narrow it down to the Morrison area, west of Mount Glennon, east of Mount Falcon, and south of Highway 74. So anyway, yeah. So if any of you folks that are into that want to take that on, I'm sure they would appreciate it. So they don't have to keep coming out here. Yes, sir.
So I thought I'd just add that up in that area, I have heard gate transmitters, cars pull up, the gate opens. It's usually like if you've got something scanning, you will hear this burst of data information. I think that's what it is. You're saying that's continuous, but
Continuous, and it's being heard 70 miles away.
So it's not low power, but I mean, I know this Chinese stuff.
Yeah, right.
I think they think, oh, we'll just put it on, you know, whatever's convenient. We got this ham radio transmitter here. We'll just use that in this gate box. So
Yeah, I sent it to a buddy of mine who's an RF engineer at Harris. And he does all kinds of crazy top secret stuff and knows signal processing inside and out. And he couldn't decode it either, but he said that it sounds kind of like one of those transmitters that they use to transmit some telemetry, like water levels or whatever it might be. And they might have misconfigured it so that it's in a ham band. But anyway, so I'm going to play a little excerpt of what it sounds like, hopefully. So that's the pulse. And here comes the data. Yeah. Yeah, so I condensed it down. Obviously, that was 2 minutes worth there. So. But yeah, you hear it sounds kind of like a modem. Sounds very PSK-like. And then keeps going back. So, yeah, kind of interesting. That reminds me, I've had, whenever I listen to the TechNet every Tuesday, I've had this weird pulse that I've heard on 2 meters that's every second. It's like static, kind of like that. And it was driving me crazy. And I finally figured it out. It was a little phone charger, one of those magnetic ones that you can click your phone into, and it was putting out a pulse every second. And the second I unplugged it, it stopped. Weird. Okay, anyway, last thing before we get into the meat of the topic here is a little bit more AI. So as you probably know, generative AI is huge nowadays. Just show of hands, how many of you folks have played with generative AI? Wow, that's not very many. Okay, well, don't be afraid of it. You can't get in too much trouble. Don't put your credit card numbers into it or your social security number, you know, don't do stupid things, in other words. But yeah, my favorite is Gemini, which is Google. Just go to gemini.google.com and you can just ask it questions. You can tell it to do things like I said, you know, write an overview of ham radio antenna theory. And it spat out like 2 pages worth. You know, I mean, it's pretty amazing what you can have these do. Part of what you can have them do is generate images. And so I got to thinking, well, I should have it to try to generate a club logo or image. So this is what I typed in, you know, a logo for the club that shows a highway sign with 285 on it, beside a 2-lane highway leading from the plains to the mountains, like right here. On the right side of the road is a Quonset hut with power lines, a 50-foot tower, and a Yagi antenna, and a cable. So,
only 50 feet.
well, so that's kind of weird. Didn't quite get the Yagi, or maybe the polarization's wrong.
Yes.
I don't know what this is going on down here in the bottom, but anyway, so there's one. That one's a little bit better.
It's kind of, yeah.
And another one.
I like that one.
Yeah, that one's better. And then this was the best one, although it looks like it's a
Solar panel.
Starlink or solar panel on top there. So then I tried Microsoft. Microsoft has one, basically the same kind of, this is called a prompt, by the way, that the thing in quotes. And it's just what you're asking it to do, right? So yeah, this one isn't too bad. There's a donut, you know, because I had asked it to add donuts, right? So it stuck a donut into the tower.
Larry.
That might be a new design. We should look into that.
That's appropriate for hand.
Magnetic
Yeah.
loop.
Yeah, and you notice the shack says donuts and coffee on it.
Love it.
Here's another one. This one, man, you got donuts everywhere this time. Looks like that one had a bite taken out of it. Then I went to DeepSeek, which is the latest one. This is Chinese.
Ooh.
And this is what caused NVIDIA stock to plummet a couple of weeks ago. And this one is photorealistic, obviously. And yeah, it's kind of cool, you know, so it's got kind of a realistic Colorado sign. And this kind of looks like Fair Play, actually.
It does. Very, very much.
Yeah, so that's kind of cool. And here's another one. This is Google's. And I don't know why it thought you to do two 285s, but anyway, and there's a big, this looks more like a commercial antenna.
They put the sign post right in the middle of the lane.
Yeah, right. I did do an inset with like a radio and a cup of coffee and some donuts. I thought there was sprinkles
I
even.
like that.
Yeah, no extra charge for the
All
sprinkles.
of them had your face in.
Yeah, well, this is Zoom doing that. And this one was kind of cool though. Look at this here. So it had a nice banner on the side here.
I like that.
And kind of a cool antenna, but and then we got this little tray table with donuts and coffee on the side of the road. I don't know why it did that. And there's another table right here. So, yeah, just bizarre. Anyway, all right, last thing for me. I've told a number of you folks, I've been, and Corey turned me on to this. Corey, the KV4P, which a guy named Vance, who's out of, I think, North Carolina, came up with this idea where he built a PC board that's got basically a RF module that you can get from China for about $10. I think it's the same module they use like in the Baofeng's radios and such.
Until Tuesday, it won't be 10 anymore.
Till Tuesday, it'll be $12 or whatever. And then there's also a ESP32 microcontroller built into that. And he did that, and then Mark Smith, who's one of the guys on the Ham Radio Workbench podcast. If you guys don't listen to that, you should. Each one of those episodes is like 2 hours long, and I always look at that and go, how am I going to listen to 2 hours? And then somehow I wind up listening to it all, you know, usually in pieces, not in one sitting. Anyway, he redesigned it. This is his design. This is the version 2 to use professional engineering techniques, because Vance is a software guy, not a hardware guy. It's got a lot of cool SMT on there, and the only thing you have to add to it is the RF module, which took me about 10 minutes flat. And then I 3D printed the case, and I attached it to my $35 burner phone, as you call it, that I bought at Best Buy, and it works great. I have it here if you guys want to plug it later on. Just got a little antenna on top, and it's remarkably capable. Puts out a watt. You can do APRS as well as FM. And I've come up with all kinds of other potential use cases for the module itself without the phone, like attaching it to a Raspberry Pi or some other microcontroller. So we'll see what we can do with it. All right, so let's move on to Larry. Are you going to do this one? Yeah.
Yeah.
By the way, this is a board, not really a board, out of a 60s TV set before they really did PC boards.
Okay. We're all gonna start out with the good old days, and actually looking back, the good old days really were not that good.
Give you a mic here.
Okay.
Try not to lower it.
Oh,
Pick that up.
it wouldn't be the first time. And you know, you look at that television set there and look at the labor that was in that thing. And of course, back in the good old days, the parts were not that cheap. You know, you take a $2 tube, you think what that would cost nowadays. Maybe $30, $40, something like that. You know, we spent a lot of time scavenging parts out of old television sets and that. And you look at the construction, and one of the things that was good practice was that when you put a lead on a terminal strip, you wrap it all the way around. And trying to find the tail end of that to be able to salvage the part in that was a pain in the rear. And again, you think in terms of the surface mount bat, how compact it is. Well, look how compact that is.
Larry,
Yes,
I was in the Navy when the memo came out. We no longer had to wrap the leads around the terminal strips. We could just put them in there and go ahead and solder them.
yep. Again, the good practice was mechanical connection first, solder connection second. And what a pain in the rear to salvage parts. And again, to do your home built projects, you pretty much needed a good workshop there, especially working with metal. And here is with dust and all, is a 160-meter mobile transmitter that my dad built probably in 1960. And again, you start looking at the circuit, and I'll pass this thing around. But again, how tight everything is in there, and I wouldn't want to do it again. Again, parts were expensive, time consuming, and Mark, you were saying electrocute me. Guess what? I've gotten across I've gotten across the B plus more than once. I've gotten across the 750 volts on the 6146s. So anyways, how good were the good old days? I don't know. Okay. See if I go the right direction here. Nope.
Yeah, there you go.
There we go. And of course, in came the solid state era. And anyone here remember what a CK722 was? Hey, we got one guy. That was one of the first commercial transistors available, which was then replaced with the 2N105. And of course, we had the 1N34s, et cetera, et cetera. But anyways, it got to be easier and easier. The labor to build something got less and less. We ended up with, a lot of printed circuit boards and things like that. You shove the leads through, and rather than wire wrapping all this stuff and running wires from point to point, basically you just loaded the board and then wave soldered it or whatever, which went much, much quicker. And again, for building things, it was a lot easier. But, again, how do you make a circuit board and that? So really, some of the things were the breadboards, which is shown up over here. And again, dust and all. Here's one that I built up maybe 10 years ago and monitored the voltage on a battery and also the antenna position with the rotor. So anyways, good example of building things on perf boards. Quick and easy. Oh, excuse me, breadboards. And then, of course, is perf boards. Thought I had an example here of that. Oh, yeah. And I just pulled off. Microphone. But anyways, here's a great example of building things on a perf board. I want to pass that on. Wire wrap. I looked for some stuff for wire wrap. And again, that was real popular with our digital technology. and high-speed digital was 30 megahertz. How far we have come. And if you're not familiar with wire wrap, you got essentially an IC socket with a square pin coming up with sharp edges. And you stick that wire down there and you twist it in, and somehow the sharp edge cuts the wire, which then makes your connection. And those things got to be one complete mess. And if you had to troubleshoot anything, where did the wire go? And they were all the same color too.
When I was in high school, we built I think it was an IMSI 8080 kit, computer kit. It was all wire wrapped, and
Yeah.
it was my high school computer club. It took us months. Wow.
Yeah.
Months and months.
Yeah. Exactly.
Yeah.
Let's see, etched up PC boards. I've never had good luck with etching a PC board. I'll pass this around later, but you got undercuts, you got areas that don't get rid of all the copper in that. It is a pain in the rear. But this is a piece of scrap board. I'll show you a technique that I've been using a lot. Let's see, what else do we have here in our magic kit?
I think I used fingernail polish the first time I did a PC board.
And
Obviously, it wasn't a 50 pins. It was back
yeah, exactly.
1965 or something like that.
Well, that's been my experience. And anyways, again, you got the other kind of boards here, which you can bridge the solder gaps with. And Rob, I think you had a bandpass filter that you built with a similar kind of thing.
Right.
Yeah,
Yeah, it's just a little board with all kinds of solder pads.
yeah,
You just poke whatever through and solder it up.
yeah. So anyways, this happened to be a hat for an Adreno. And I was trying to interface my K3 with an Adreno, which then interfaced with the amplifier and antenna, et cetera, et cetera, et cetera. And a lot of problem with RF getting in there, and I ended up with optical isolators and a whole bunch of other crap, but another example. Let's see.
Is
And
there anyone who hasn't seen this yet?
everyone sign in?
Over here.
We go.
Ready.
I don't think these guys saw it.
So anyways, and again, what you can do with the ferric
Yeah.
chloride once you're done with it, dump it on the ground or whatever, caustic chemicals, really wasn't that great. The good news is the parts were cheap enough that you didn't have to scavenge things off of old television sets, even though I still do. And also, if you're working with integrated circuits, a huge amount of the wiring was done for you. So, really life got easier in many, many ways. Let's see, what else do we have here?
Thank you.
Yep.
Whoop, that's the light. Whoop, did I jump to? Yeah. Okay, the breadboard here, again, is really inexpensive if you don't have to have a power supply on it. And I think things like your old, your old computer, your old computer power supplies make a wonderful 12 volt, 5 volt, 3.3 volt supply. So if you have an old computer that you can scavenge a power supply out of.
Yeah.
Again, just buy something like, if I can find this next one here.
And you can even buy a breakout board from, I think Micro Center sells them and Adafruit, which will plug into the header that comes off of the computer power supplies.
Okay,
And gives you a ramp with all the voltages and everything.
oh, yeah, here's a good example of one that, I got off eBay, I think the package was like 5 of them or something like that, so, for not much money.
Pen for a second.
Let's see. What else do we have here? Okay, modern board construction techniques, and Dave, you have the experience here with that. Especially with. Yes, you do. You're shaking your head now.
I'm just oblivious. I only have 1 cup of coffee. I'm not even awake.
But, no, but anyways, Dave has done a huge amount with board design and having the manufacturer and everything else. And again, surface mount, Mark, I think you mentioned, you were surprised how easy it is. Dave, you may want to talk about the learning curve, at least to have commercial boards that built. Parts are now cheap. An assortment of maybe 2,000 resistors on eBay, $15. It's nothing. And you don't need a whole lot of tools. So anyways, a good soldering iron. I think I could build stuff with a surface mount with an old-fashioned solder gun. I wouldn't want to do it that way, but I could do it. Good soldering iron, reading and magnifying glass, and some tweezers. It's pretty much all you need. Okay. Dave, you want to talk about the Manhattan process here?
The Manhattan Project.
Come on up here. I'll give you a microphone.
Good morning, Larry. Good afternoon.
Good morning.
And which is the self-destruct button?
It's the right arrow will move you forward.
Okay.
And the top one is the laser pointer if you need it.
DD 104. Get this.
Just a side note, if you're gonna do low temperature soldering using a hot plate, be very careful about where you get your hot plate. I learned a lesson the hard way, doing some of that work. And, the hot plate I had was in a lab and it had a magnetic stirrer on it. So when I put the board on the hot plate to, install the components, there's a lot of components out there that are ferromagnetic and magnetic stirrers a very powerful magnetic field. So they just pop off the board. Wow. Off the board. So, if you're gonna use a hot plate, make sure you don't get one with a magnetic stirrer feature.
And actually, Dave, I think you've had problems with magnetic tweezers.
And some of the little teeny surface mount parts, which are like grain of sand time, and an essential hand tool is a pair of tweezers. Like you do women's cosmetics, pluck eyebrows, tweezers like that. Some of them have a little magnetic effect, and now you've got this little teeny part that weighs nothing, attached itself to your tweezers, but can't get it to sit down on the board. Let's see, Manhattan. This is when I started early in my career in the early 80s in a cable TV hardware equipment manufacturer. The engineer in charge used exactly this method to build prototypes of circuits, just a little blob of solder to hold the end of the wire down onto a piece of copper clad fiberglass, which is circuit board material. And you can do this. You can buy a square section of this material. It's typically a 1/16 of an inch thick. It has copper on one or both sides, and clean the copper with a little bit of steel wool. Take your soldering iron and some solder, and hold the part down. It becomes a 3-handed project, and that's why you need 3 hands. And this became called Manhattan because the
projects that you would build would have parts standing vertically, kind of like a distant view of the photograph of the island in Manhattan in New York City. It actually works well for a lot of kinds of circuitry if you want to build one thing without requiring any special tooling. You can buy the circuit board material on eBay or Amazon. You can cut it with a paper shear. You can buy a paper shear or find one at an office supply or at a flea market somewhere. And it's a big knife pivoted off the piece of wood, and that will cut this material very effectively. Let's see, so is this, these become lots and lots of words on the screen. Is this material going to be available online?
Already on the club website.
Cool, so I wrote this figuring, this part that I wrote figured a lot of details and not worth trying to memorize, but it's available online. So let me go back a couple. This upper right corner is a surface mount from the circuit board, and that's where this part of the discussion is going to go. It's going to go by pretty quickly, a lot of detail, come back if needed. Remember earlier in the presentation about you had to route the wire through the soldering lug and wrap it around a few times before you solder it. And it was kind of a pain to disassemble, to salvage parts, but I remember that was the procedure in a Heathkit manual to assemble an AM radio from the early 1960s that I'm seeing my dad build one of these on the kitchen table, and he had a big welder soldering gun. And I just remember looking, and I'm sort of 7 years old, and the tip is glowing red. And he's got this heavy solder and this lug and wire. Oh my God.
I still have one of those irons.
It worked sort of. And eventually the Navy, as I now learned, I hadn't heard that, but it makes perfect sense. The solder was considered strong enough to hold the wire in place. You didn't need to wrap it. And eventually you went to a circuit board where, was there a circuit board showing the whole parts going through? Well, the idea was this lower right corner of this picture, here is a circuit board, and you took like a resistor with two wires, you poke the wires down through the circuit board. That's called through-hole construction. And you would solder with soldering iron the point where the wire enters and exits the circuit board, and now you've put a part on the circuit board. Again, disassembly to salvage parts becomes kind of time consuming, but it's possible. You have to heat the board up enough with a blowtorch or a hot air gun and pull the part out with tweezers. It's doable, but the parts are often so cheap, why bother? And eventually, again, you're not, the wire is what holds it in place, but the solder is doing the job. So why bother going through the circuit board? Why not just have a blob of solder on one side of the circuit board holding the part on? That's where this Manhattan construction kind of inspired the idea. And eventually all this comes together and we go into self-destruct mode and becomes a circuit board properly up here. These parts no longer go through the board at all. The parts don't even have wires generally. You hold the part on the board and you just apply a little dab of solder where the part touches the board's copper surface, and that's what holds the parts in place. And that's considered reliable enough that's used for satellites. It's used for safety things like electronics in an airplane and so on. So it's the way construction happens nowadays. So that's really where this discussion begins, is first order of business is in kit building, which will be a topic in a month or so from now. The circuit board is a given. You order a kit online and it arrives, and you've got a circuit board, a little bag of parts, and some instructions is pretty common. And how do you get the parts on the circuit board? Well, we're going to demonstrate that here in a little bit. But the circuit board is a given. The question comes up, suppose I want to design my own circuit and I want my own custom circuit board. It's been possible to make a custom circuit board for some decades. In the early part of my career in 1980-81, I said, I want to build an HF power amplifier using one of these newfangled transistors that'll give me 25 watts on 40 meter band. And in the Motorola is a common name that built parts like transistors. And I found the Motorola catalog. And there is a picture in one of the pages of the data catalog of the design of a power amplifier for 25 watts on HF bands using a circuit board. And the company I worked for said, like my boss, how do I get a circuit board made? oh, you just take the photograph of the board and you send it, give it to the manufacturer. This is in Los Angeles, or everybody's manufactured in Los Angeles. We drive over, I give them the page out of the catalogs. I want these circuit boards made. Well, it's going to be $120 engineering charge to have the artwork taken from the page in the catalog, which is just a black and white print of the board. And we'll put it in our system and you'll get 5 circuits. $125 is a lot of money in 1984, 83, 82, somewhere in that range, but that's what I did. The boards came back and, oh, great, I've got the transistor, I've got the board, I've got the parts. And the board was about 2/3 of the size it should have been. So the boards became what are now known in modern vernacular as a coaster. And a coaster is a board which didn't work out for one reason or another. It's like the little thing you put your coffee cup on and you can mar your kitchen table. Luckily, that idea of taking a photograph to make a circuit board was common for some decades. And we fast forward to the 1990s, you could still do this. And this is where this idea of, can I get this printed image transferred like a photocopier onto the surface of the board, etch away the copper with chemical called ferric chloride, which is kind of nasty, and you get a mediocre quality circuit board derived from a printed image. But we fast forward a couple more decades, we come to the year 2005, 2010, and we can now use a computer to create the artwork for a circuit board as a data file. We send that data file to a company, and now, depending on where the company is, they'll take that data file and produce a circuit board for you to build your project. Here we are in year 2025. That process, the software is free. The computer is something almost everybody's got one. The data file is a standard format called a Gerber file, G-E-R-B-E-R. And if I go online, I can find companies, they're almost entirely in China, but they're not exclusively. There are some in the US. And you can send the Gerber file to this company, and they will put it in a semi-automated machine that marks out 10 circuit boards. Within some constraints, you can get 10 very high quality circuit boards made for a total cost of between $5 and $10 shipped to you. These are very, very high quality boards. They look professional because they're the same exact board manufacturing process that goes in your PC or goes in your AM/FM clock radio. So this business of being able to make these circuit boards so cheaply, coupled with parts that are so cheap, it changes the entire dynamic of home brewing for ham radio. But there's some new tools and new skills learned. But the fact that the cost is practically zero makes the learning curve, in my opinion, worthwhile. So now, with that said, here we are. How do I get the circuit board from an idea? I want to build a, what was it? You got a low pass filter or a band pass filter for your antenna?
It's a 20-meter band pass filter.
Let's use that as our mule example. We want a 20-meter band pass filter. The parts on it is going to be a handful of small toroid cores, one with wire, and a small number of capacitors and a pair of connectors. You can look up on the ARRL handbook, or you can look up online, or you can just use your experience as an electronics technician or engineer and say, well, the toroid cores are about 1/2 inch around and they've got 2 wires each. The capacitors are sort of 1/8 of an inch by 1/8 of an inch size. And we need a handful of those things. And how do I make the little traces on the circuit board match? And I want my circuit board, looks like that thing's about 1 by 3 inches or so.
Yeah.
So let's start from that point. Well, you can get to a schematic diagram. How do you make a bandpass filter? You have some series inductors, parallel capacitors, and so on. And you hand draw or just put in your head a schematic diagram of the circuit you want to make called the bandpass filter. You know physically the size of the parts. What would I want if I had my druthers for a circuit board that had the traces and the positions to match that circuit into a 1 by 3 inch piece of material, with the prerogative that I can have some of those conductive traces on the bottom side of the board and some on the top side. It's called a double-sided circuit board. And that comes kind of for free nowadays. That was considered exotic technology 50 years ago, and now it's essentially free. So this is where your computer comes in. Now, it would be possible to make this circuit board out of without a computer, without a service, without any software, on a piece of this copper clad material we talked about 10 minutes ago. Using an X-Acto knife, you can cut away the copper, peel it away, what's remaining are tracks, and it's sort of like Manhattan design, except you have the copper traces on the board rather than the wires that are done point-to-point wiring. It's tedious, it's possible to do. I had in my original draft of this that the cutting of the copper away, you can also cut your fingers away, it works just as easily. Not recommended, but it's possible. But let's set aside, what would we want to do if we wanted to make a more complex board? Well, quickly that hand cutting and scraping and chemical etching becomes a huge time sink for those of us who don't have a whole lot of time to spend on this stuff. So I would go down to your computer, go on the internet and download a program called KiCad. I think it's pronounced KiCad. In any event, look up KiCad. It's a software program. It's free. You download it. It runs on your computer. There will be some learning curve, but there is a zillion YouTube videos if you like learning from YouTube. That's a great way to get started. I don't, therefore I read the manual and it's a big pain in the butt, but nonetheless, you can learn. It is laying out a circuit board on a KiCad or laying out a schematic is point, select the part, click, drag to another location, that becomes a wire, and it becomes a symbolic representation of your schematic. You can go through some procedures where it will then place the parts, saying, I want all these parts of my bandpass filter to fit in a 1x3 inch space. So you tell KiCad my board is 1 by 3 inches. I'm glossing over a lot of steps, but you push a button and it will place for you the routing of the traces that would appear on the board that you want built. You then push another button and out comes this Gerber file. And a Gerber file is a few hundred bytes long. It's typically a very small file. And if you look inside the constituents of that file, it's just a bunch of numbers. And those numbers are formatted and those numbers are interpreted by your manufacturer of circuit boards saying, I want holes going here, I want traces going there. And I want the lettering on the board and I want the other layers and processing. And what will happen is if I ship that Gerber file off and my $5 to $10, and within a few days to a couple of weeks, depending on which service you use, you get a little packet of typically 5 or 10 identical circuit boards, in this case 1 by 3 inches, on which I can solder capacitors and toroid coils to make my bandpass filter. There is my project, and using a circuit board just like the professionals do, except that it was my own personal design. Corey has got an example of a circuit board that was used for a QRP radio project called True SDX. In this case, it was the same process except for one detail. The person in Germany, DL2MAN, his name is Manuel, he designed using some software like KiCad, got the schematic entered for this QRP ham radio transceiver, pushed the button, out came a Gerber file, sent it off to some outfit in China, but he had an additional request beyond just the making of the circuit board itself. He said, you guys go to your parts bins, pick out the parts, place the parts and solder them and send me back a constructed circuit board. That becomes an option that's also quite cheap nowadays, and it even eliminates the need to solder these tiny parts yourself onto the circuit board. We'll go into that further detail, but it's well within the range of a hobbyist ham operator to make an electronic project now where you're on your computer and after a short matter of time and money comes back the already constructed transceiver or bandpass filter or whatever. And they even did the sourcing of parts and the placement and the soldering of the parts for you and the testing of the resulting board. All of this is practical. It wouldn't have been so practical 20 years ago.
Do you think they manually place the parts?
They do not. The parts, that's an excellent question. The parts arrive in what's called a tape and reel format. So it looks like an old remember the old reel-to-reel tape recorders from the 1950s? The 7-inch reel with 1/4-inch magnetic tape. Because I remember when I was growing up as a little kid, my dad would bring home this tape recorder and we'd record our voice as little kids. I still have the tape of me talking in 1960, sort of babbling incoherently, and there's the tape. I just don't have a tape player to play the thing. Those same plastic reels were adopted by the packagers of electronic components. So when In the world of capacitors, we all know what those are. The number of capacitors that's made every year is in the trillions. These capacitors are typically quite small, typically 1/8 of an inch long, with no wires, little block of capacitor material. And they're put on a perforated paper tape. It's about 3/8 of an inch wide, the little holes every 1/10 of an inch. Little parts are seated in there. We've got one right here. Yep. You can look up closely, come by and take a look at it. These parts are going to be in the demo of how do we solder things here shortly, if I can get off and stop babbling. And a reel contains between 2,000 and 5,000 parts, identical parts typically. So a 1 microfarad capacitor, a reel of those, 5,000 parts on a 7-inch reel that looks just like it came out of the 1950s tape recorder. That reel of capacitors, if you were to buy the whole reel, might cost $10 to $20. The parts are less than 1 penny a piece. They're so cheap that because I often screw up something when I'm building something on my workbench and the part flies off the end of my tweezers, I don't bother searching for it. I'll just grab another one. It gets picked up by the vacuum cleaner and out with the trash. Just an amazing evolution. Which is a brief aside, I have made a recommendation. You might want to consider 285 Tech Connect create what's called a parts library is not the proper term, a parts share, basically pooling parts and then saying if you need 10 of these things, don't buy it online. Just here's a list of what we've got available in the club. They just mail you. That's done by some other other PAM organizations, and it works real well. So long story about KiCad and software and having boards made. There's another software program which is better aligned with Larry's work with the this computer numerical control glorified router called FreeCAD. It's used for creating not just electronic designs, but mechanical design. I want a little box or a housing or an enclosure. Tinkercad's another one. It's more geared to 3D printing. This is something that Corey had introduced me to, the whole idea of designing for 3D printing. I want a box. Well, a box is a rectangular thing with a third dimension that has got walls in the base, and you can edit these on a computer. Not so specific to electronic circuit boards, but very helpful for enclosures, things like that. In any event, the output for circuit board manufacturing is this thing called a Gerber file. I don't know that Gerber is even an acronym. It's often capitalized. I don't know its history, but it is a established.
They've been called Gerber from really early layout.
Well, maybe the first engineer was 6 years old and got right out of food feeding baby food.
And that's the original software company's founder or so.
We talked about WireWrap a little bit. WireWrap is actually a trade name of a company that developed the tool and the standard for this called Gardner Denver, which was up in Denver somewhere in the 1960s. So Denver plays a little bit of history in that. In any event, when I want to have circuit boards made commercially, a Gerber file is the standard format. If I want to have a machine like this, a computer numerical control machine, etch the copper or mill the copper away, there's another similar file format called G code. And it's an abbreviation for something that I don't remember. But they're not the same file, but they're the similar concept. It's an expression of a thing which a machine or a company running a machine can use to have fabricating a physical object. The circuit board material, you'll hear the term called FR4. FR stands for flame retardant, very important. In the early days, circuit boards were designed using a fiberglass material which would burn, which is bad for an electrical circuit. It failed. So in any event, this is almost entirely universal. If you're looking for circuit board material and you see the term FR4, know that it's a low cost, widely available fiberglass composite with copper applied to either or both sides, or sometimes no side. Common thickness is 1/16 of an inch. That's often called 60 mils, MIL. That's 1,000th of an inch, also known as 1.6 millimeters. That's the most common thickness of circuit board material. You can get thinner, you can get thicker, but that's 1/16 of an inch is almost, I will almost be certain that that's the thickness on your bandpass filter material. You measured it. The copper, you'll hear the term 1 ounce copper or ½ ounce copper or 2 ounce copper. That's a archaic way, but it became a standard for how thick is the copper on the line, the top and the bottom of the circuit board material. 1 ounce is very universal, means 1 ounce of copper metal flattened and spread out over a 1 square foot area. It corresponds to some microns of thickness. So if somebody says, I'm going to build you a circuit board with 1 ounce copper or ½ ounce copper, build it, be happy. If you want something which is thicker, it quickly becomes more expensive. You'll hear a term called plated through holes. And I want to go back to one of Larry's slides here. This etched circuit board on the lower right corner is the fundamental 2-layer, that is bottom and top circuit board, possibly chemically etched or mechanically milled in this case. And you'll see the greenish material is the FR4 fiberglass material. The orangish material is the copper that's been left over after removal of the excess for the conductive traces. And the holes that are drilled for these sections go through the board from one top to the bottom. In a board that's made on a CNC machine, like you're going to see as an example, there is no electrical conductivity in the hole that connects the bottom trace to the top trace. So when you're putting a wire in, you need to solder the wire. In a circuit board that's made commercially, that was solved by a technology called plated through holes. Now the process is deep in the bowels of automated circuit board manufacturer. But when you go online for your $5 to $10 batch of 10 boards, those top and bottom layers will be by default connected with a plating that actually goes through the hole that's been drilled in the board for you. Great simplification for construction. VIA, vertical interconnect access, and I think that's the term I have always taken for granted. Well, it was just via a path from somewhere else, but nonetheless, it said this is just a way when I've got a circuit trace on one side of the board to get the power or circuit signal connected to another trace on the bottom side of the board. This is going to get a little repetitive because I've covered some of these before, but the basic way to get a circuit board is you start from an idea, get to a schematic, get to a Gerber file. This is step by step, and you send the Gerber file out with your credit card number, or PayPal account, or some cash, and you'll come back with a pile of circuit boards, or they'll become coasters if they didn't work right. But it's not catastrophic. If your board is laid out and there's an error, you can take the knife, cut the trace, called cut and jumper, so you can make corrections to an already fabricated circuit board to fix problems. Or in the most severe case, you just change your design and have another batch of boards made, and you would now have 3 coasters. This is a picture on the right is a version of the CNC machine that Larry will show. When I first met Larry, about a year ago or so, and he's telling me about a CNC machine that I go, because I live about a mile from here over to Larry's place. Hey, how cool is that? We're going to do this. It was last summer, I think, and then before the fire hit in Jefferson County, Douglas County, Jefferson County. And I came away and I said to my wife, who's a woodworking specialist, we were both retired, wouldn't it be cool to have a CNC machine at home? And about a month later, we go on to the wood supply store in South Denver, want to order one of these, and this thing arrives on a pallet about a month and a half later. It's the size of a washing machine. It's sitting in the sunroom of the house. And it's a very nice CNC machine that I have yet to use, much to my wife's consternation, because I have so many other projects. You've heard this problem of too many projects, not enough time. Because, I'm very much subject to that. Nonetheless, you end up with a circuit board called a PCB. How do I get from a circuit board to an assembly? Well, I can buy the parts, get them from my club, assemble the parts. We'll see a little demo of that. Or I can send an additional piece of information to my circuit board shop saying, here are the parts, here's where they go, and I want you to place the parts. I'm going to come all the way back to your question about how do they know where to put the parts? Well, these parts fabrication machines, which are size of half this room, have a batch of those reels of parts. Say I'm going to use a 1 microfarad capacitor and a 1K resistor and a 1 microhenry inductor and a 74 CMOS HC04 inverter. And I got this list of parts. All of those parts were in the warehouse of the manufacturer of circuit boards, each one on one of these 7-inch reels at very, very low cost, but in vast quantities. they place, and too bad we don't have a photograph of this, but you'll walk up to this machine and it's got dozens and dozens of these reels of parts coming down on this paper tape that looks like a paper version of an old audio tape, music tape, going to this machine that looks kind of like a CNC machine, and it guides that part into position and plops it down on the circuit board, where previously some soldered paste was laid out on the circuit board. The board gets loaded with parts through an entirely computer-controlled process and then shoved into what's called a reflow oven. Just think a glorified toaster oven, and out comes your finished circuit board with parts on it. You now have what's called
There's a shot of,
Taking place.
one of the machines right there.
this. That
Looks like it's placing components or something.
So this is what's happening, and the cost of this is in the having a board like the bandpass filter made with pick and place. Might be $50 to have 10 completed bandpass filter boards made from your fabricator. In this case, I just sent them data files and some more money and came back already finished bandpass filters. So you don't actually need to even solder parts or deal with part procurement. So these are very accessible to hands and other hobbyists. There's a hand friend of mine in Portland who does this all the time, building transceivers and related things. And he doesn't like to solder, so he just says, I want to make sure those parts are available to that manufacturer, and I get 10 copies of this. Would you like to buy them? So let's see, here we are. I'm now going to hand it back to Larry, who will go into mechanisms to make a circuit board at home. Okay, so I'm gonna give you your D104 back.
Yeah,
And
I wonder how many people will remember what a D104 is.
Lollipop.
there you go.
Yeah. Okay, the question gets to be is, let's say you don't want to go through the learning curve and everything else. You want to do the bandpass filter. And I have had great luck with the spot weld cutter. And I don't know if you want to get in here and zoom in, but it's a simple process. And Rob, like your bandpass filter, I think that you really only have 3 connections. You have the what you have going from the connector to a pad of some kind to ground, jumping to another connector, to another pad and to ground and to your final output. And so the question is, what would you do for a quick and dirty that you don't have to go through CAD, you don't have to wait for a week, et cetera, et cetera. And I don't know if you'd want to get in here with the mic, go with your camera or not.
Yeah, give it a shot.
But we're starting the physical demonstration and expect things to go wrong. They never go right. But anyways, the spot weld cutter here used to be available at Harbor Freight. Let's see. I'll pass this around for about $5 or a little bit less. I see them now on the web and also on Amazon for roughly $10 to $20, and you end up with a whole bunch of spare heads in there. So, well, why don't I go ahead? It's simply a spring-loaded pin here to center it to keep the little hole cutter here from wandering around too bad. So anyways, it's simply I wasn't on your square. do. And Rob, if you wanted to build your little filter in that, essentially connector coming in here, your capacitor and coil to ground, another coil here, capacitor and coil to ground. And I ran out of old PC material, so anyways, I grabbed this thing here. And this is one that I etched, and you can also see where it did not etch correctly. But it's as quick as that. And if you want to do double-sided, essentially drill a hole in the center of the thing and use that hole then to line up the backside. And again, use a spot weld cutter to cut a hole. So anyways, this becomes easy double-sided material. And, oh, the other thing I might mention to you is with soldering things not in holes, what I like to do is I like to bend about 180-degree bend on the lead, solder it in place, and then I clip off the lead. But I know I'm gonna have to change parts. I know I'm gonna make mistakes, and so that gives you a little tab that with the, with the pair of long nose, you can just pick and move. Real easy to pull off. And they don't have to be simple designs. Here's another example of the thing. This is a little RF amplifier. And I've got the IC here. It's an SOIC, which you mount on and you use the jumper wires to get around it. Let's see, what other wonderful things do I have here? I think that's it. Do we want to do the examples here of the CNC? Okay. Let me turn on power. While we're doing that, here is the little cutter wheel. And you may notice when you pass it around that you can unscrew it, flip it over, and you got another set of sharp holes on it. So it's fully reversible. This out of the way. Oh, okay. Okay, I guess we're pretty good here. All I have to do is hit print. And one more. And we'll see if we can break the mill. Good. I might be moving just a little fast here, but that I bet that there seems to be a little bit on the go side. And this is the program for the little 26 DD annual. And I think I have 17 kits here that are pulled together that, it's free to take. Stuff's made out of scrap PC board, so no cost there. The resistors and that were under $3 or 50 of them.
Larry, what does that machine run? How much for that?
I got this as an open box for $130. New, their exchange part is I think 190 or something like that, not open box. I have no problem with an open box.
Yeah.
And right now it's going through some stuff, because what I've programmed it to do is basically to do another board, you know, for making the ones for the kit. I just put a long piece of PC board in there and every time it did one, I'd hit start again. Okay, let's see if we can pop that off. That is what it takes.
He's under the microscope.
Okay, and actually, Dave, if you wanna, actually solder one up. And the big long strip there was, the actually the 51 ohm resistors and,
Okay.
and that one there is the
So
five.
let's see, where are we're gonna work under this as far as the,
Okay, great.
because this is visible, okay.
Yeah. Here's your solid base,
Okay.
here's your iron hot.
Will be, yeah, it's one of those.
Okay,
Wakes up with. Cool, all right.
the thought is that we'll do one with the standard old soldering technique, and typically what seems to work the best
Yeah, I'm
is
gonna
to
kind of just
put a
keep an eye
little
on
pad of
the
solder
when he gets in position.
on one side with tweezers and that, you place the part, you tap that side, and then you go back to the other side and solder it in. And so it really goes pretty quick.
So what this is the physical circuit board, in this case, is this side. So about an inch and a quarter by 3/4 of an inch. The material is a 16th of an inch. Okay, we're gonna go back to the D104.
Yeah.
I can tell when that happens. Okay. Hello on the radio. 4 score and 27 minutes ago. Okay, so typical FR4 circuit board material. In this case, it's called single-sided, so it's a slab of 16th-inch fiberglass stuff called FR4. The copper is only on one side. It began life as a 1 ounce copper, which means 1 ounce of copper flattened into a foil, which is adhered to the circuit board material. And then Larry's CNC machine milled away the copper to leave some conductive traces. At that point, the whole thing, this microscope is a little bit more powerful, but the operative thing is right here. Is the horizontal line to the left is a conductive trace. It's going to carry radio power. The horizontal line to the right is another conductive trace. The big line on the top and the big line on the bottom would be used as a ground reference. All the signals are happening on one side of the board. And what we're going to do is we're going to plop a couple of surface mount resistors onto this. And in order to make this stable, do we have any tape, any Scotch tape or? Yeah. Oh, okay. Masking tape. I want to, I'm going to tape the circuit board onto this pile so that it doesn't move around when we're trying to work with it. And so, and what we'll do is I'll then take a brief commercial break to say, if you want to do this at home, useful things to have. To help with surface mount construction is some method of magnifying your work. You can use one of these little, what's called a jeweler's loop. It's a little magnifying attachment for your eyeglasses. You can use, I use a kid's stereo microscope I bought on Amazon for about $30, which has lasted me for some years. You can get one of these USB imager magnifiers online. One of these things will cost $30, $40, $50, $60, depending. Sometimes they come with a screen. Sometimes they're just for a PC and you connect it to a computer. And so one essential part is magnification. It is hard, as I'm finding getting older. My eyes don't focus in as well as they once did. And so the parts become a little bit too small for me to see. So magnifying is pretty essential. Lots of light. In this case, there's a light emitted white LED in the little imager. And I use a couple of those guard lighting fixtures you get for illuminating guard walkways. Okay. I just have a couple of those on my workbench.
Okay, sure.
They power off 12 volts and it makes a really bright light. It helps a lot. The principal other tool is a pair of tweezers. These things are like everything else, relatively cheap. You can buy them by the 3-pack or a dozen on Amazon, eBay, online, etc. Recommended to get one of they're called a fine point tweezers, and they're sold primarily for cosmetics use. So if your woman in your life decides to go have eyebrows plucked, they'll use a little teeny tweezers, and those things, that's their primary use, but they're really good for handling tiny electronic parts. It is not very practical to handle the electronic parts like a resistor or capacitor directly with your fingers, because your fingers are massive compared to the size of the part.
And if you need some, Dave has, I have some here that you can have.
So this, we talked about before, your question about how do the parts get onto the board, and they begin life in these reels. This is called cut tape. This is about a 5-inch long piece of heavy duty paper with a clear film on one side, and there's little cavities about 5 per inch of the electronic part. Yeah. These came from a reel, 7-inch reel style tape, which might have 5,000 of these parts on it. So if you go online and say, I want to buy some 1K ohm resistors.
And notice, Dave, if I can interrupt, notice that every resistor is printed on what the value is. How they can print that small, I don't know.
And so most of these parts are pre-printed. However, note quick reference, capacitor parts by standard are rarely printed with the numbers on them, and therefore they all look identical. So when you get your parts, be sure to keep them separated because they're not individually labeled. The resistors are, and you can tell
So
in
that's
this.
scary.
And so
How would you find out your resonant frequency? If something's not right, or
did I pick the wrong part and put it on the board?
Yeah.
Or even more insidious, was the parts that I got from some anonymous Chinese seller online actually the parts that are labeled?
Yeah.
Occasionally that mistake is made innocently or otherwise. There is make a note of this, it's not in the presentation. You can get a device called a smart tweezers, is what they're commonly called. What it is a multimeter bonded to a tweezer. You take the thing and you tweeze up the part and it says, oh, you got a 0.1 microfarad capacity.
wow.
That has saved my bottom any number of times. But the good news is the parts are so cheap, as long as once you determine and that's the nice thing with these reels, once you measure one, just put a mark on the back of the reel with an inky pen and you'll keep track of what it is. Yes.
You also want to be careful with SMT parts, how you breathe.
Yeah.
You can just go like, and there's a line on there.
Yes.
So you have to be really careful about how you breathe. I mean, you think it's funny, but I've assembled a lot of stuff.
I've also sent some parts flying with just mishandling the tweezer.
Yes.
Too much tension on the tweezer. It takes a little getting used to, but so did straightening the parts on the resistor from 1964, wrapping it around the lug and soldering the thing. It's just a different learning curve, but it's not inherently any more or less difficult. So what we're going to do now is we're going to begin by soldering a resistor onto this board using wire solder. Here is wire solder. You can get what's called lead-free wire solder. Solder wire comes as typically an alloy of tin and lead, and in modern times there are tin and other things. This reel is of tin and lead solder. Tin and lead is, this particular, it's actually not sold by gauge, it's sold by outside diameter. This is 1/32 of an inch outside diameter, a little less than a millimeter. This is a very common, this is probably the most common wire solder used for homebrew ham electronics. It is not used commercially because beginning about 15 or 20 years ago, lead was determined to be a toxin. If little kids ate it by peeling the lead-based paint from their house and making a meal out of it, not good for the little kid. That became something called ROHS, which is an acronym that does have a definition called Reduction of Hazardous Substances. This caused the commercial electronics manufacturers to have to not use lead-based solder. The replacements are still tin, but they're tin alloyed with other materials, typically copper, antimony, and some other alloys. And there are some types of solder that are exotics that have very low melting point that use bismuth or indium in their composition. But as hobbyists, we're going to continue to use lead 6337 alloy solder because it is friendly, works well, and we don't care. We just wash your hands after handling this stuff before you make your steak for dinner.
Yeah, I stopped eating it a long time ago, so it's.
Did they start, I heard rumors that they were having problems with the lead-free on some of the early electronics, that they were starting to grow fingers and shorting whiskers, they were shorting things out. And I heard some of my friends who were into heavy construction, electronic construction, they hated working with the lead-free because it was so hard to work with. Has that changed today?
No, it's hard to work with. The lead-free works well. Lead-free works well if your name is Tim Cook and you run Apple Computer and you can afford to have 1 billion iPhones made by factories in China because they tune their processes to not have manufacturing defects. But is it difficult to work with? Yes, for this reason. I'm going to come back to your question in a moment. Hold the thought. Don't go away something like that. In the copper ferric fiberglass composite, what we're looking at in the circuit board material, the boundary between the copper and the fiberglass has something called a transition temperature. It's called T sub G. That's the temperature where the adhesion between the copper and the fiberglass gives up. You could literally, you get the temperature up to a point, the copper will come away from the fiberglass. Really bad for a circuit board. The T sub G of FR4 is sort of in the 800-degree range. It means if I keep my soldering iron in the mundo, I can actually heat it up to the point where the copper can be peeled away from the fiberglass. Fortunately, the tin lead solder alloy that we commonly use, it has a working temperature of about 650 degrees Fahrenheit. If you've got a temperature soldering iron, you can adjust the temperature in digits. Set it about 650, life is good. Set it 850, you're going to run the risk of lifting the copper away from the board. Now you've mangled your board and created another coaster. If you are really worried about having lead in your circuit board because your 2-year-old's going to come across and eat your latest transceiver for dinner, you can use lead-free solder. There are alloys, typically copper, tin, and some others. The problem is their melting point's a lot higher. So it has to be in the 700-some degree range. You're getting perilously close to the transition temperature of your FR4 circuit board. So you have to run a higher temperature to melt or remelt lead-free solder, and you increase the risk of damaging the circuit board material. Recommendation, keep your 2-year-old away from your QRP transceiver and use leaded solder. Go ahead.
I'm just old fashioned kind
You
of guy.
also say there was some lower temperature lead.
Yes, they do exist. Look for a solder alloy that's based on bismuth. It's an element in the periodic chart Bi, and there are some bismuth-based solders that are sort of half bismuth, half tin. Those have a lower melting point than this stuff. However, they have some brittle problems with the pliability, the ductility of the material, which makes them a little bit less reliable. And if you really want to be crazy, you can get solders that are based on the indium element. Some of those have yet lower melting temperature. There is a company called Chipquik, CHIPQUIK. You can buy small runs of bismuth or Indian-based solder. You can use that as a disassembly tool. If I've got a complex chip, it runs at a lower temperature to help you melt the solder away to pull a complex part off the board for rework. That's kind of the only place that you would normally use that. I don't even bother with that. I just use a hot air machine, and we'll come to that in a little bit. What do you?
Yeah, the low temp solder you can also get it. It's kind of like a paste. Get it in a syringe. That's what I found is the easiest thing
Yeah.
to deal with. But getting back to solder, old fashioned kind of guy. I like lead tin. It's easier to inspect. Or, lead free solders. It's really hard to tell the quality of a joint.
Yeah.
In addition,
sort of opaque look.
be very careful using lead free solder because the flux you get with it is extremely toxic. As soon as you start soldering, you're going to inhale. So that's another reason why in the R&D lab where I used to work in, always use the lead tin solder. It was easier to work with the rosin as it smoked off. It was not hazardous. Tree style.
I just play Moody Blues, Free People Gathering Loom.
Everybody has their own techniques, don't they? But that's why I always stuck with lead tin. And the other thing is we're reworking a board with lead free on it. And you usually kind of rosin. Be careful with that stuff. It's really bad. Yeah, so you have to actually use an air sucking system to actually process and filter out the bad chemicals generated by the flux.
So they want to protect kids, but they want you to.
Oh, fun.
Okay.
Yeah, so go ahead, please.
I'm just gonna say that that's why NASA still uses lead. Tin lead on all the rockets. Because I finished the work at Mark. He took him months to take his solder up and have the inspector pass it. They experimented with the silver solder. They could not tell if the silver solder had a cold joint or not from its appearance.
Right.
And that's essentially, that is the problem.
Yeah.
It looks pretty crappy, probably because it is. Any last questions, comments before I go in and burn my fingers? Okay.
Burn away.
Okay, so here we have. What I'm going to do now is, what we have here is 6337 solder lead alloy, 1/32 of an inch. It is the most common solder for home projects. I use this. A roll this size weighs about a pound. It'll cost you, if you buy it new, $30 to $40, maybe less. I go through a roll like this about every 2 years, and I build a fair bit of stuff. So this is sort of like the rest of the stuff in my lab, a multiple lifetime supply. What we have here is a solder iron. This solder iron, the solder station is set to 650 degrees Fahrenheit. That's a good temperature for handling home construction using this leaded software or solder. It's about 200 degrees lower than what's called, remember that transition point? So we're not likely to lift the copper foil off the board, which kind of ruined your day. Here is a pair of tweezers. These are, they're on the floor. These are sufficient. They're not really sharp, fine tip, but they're sufficient for the size of part we're using. What I'm going to do is grab this resistor that was peeled off the tape. This comes back to your question about how do the parts get in place. This is doing it manually. In a commercial shop, a machine places the part on a board which already has little blobs of solder on it. And I'll show you here, if I get into the focal range, this part is a resistor. The two silver ends are the modern version of the wires on a resistor that you could get out of your 1957 color TV. The numbering on this says, I think I've got this upside down, or it's inverting on the camera, but this is a 510 ohm resistor. How do I tell? The digits are 511. I think this is reversing the image on the camera. Yeah. The 511 means The first two digits are the first two digits of the value, and then the last digit's the number of zeros. So 511 means 510. 510 means 51 ohms. 512 would mean 5.1 K ohms. 514 is half a meg ohm. 515 is 5 meg ohms. And thus we go. That's a very common way for resistors to be categorized. However, there is no indication of the percent tolerance. Is it a 5% resistor or a 1%? What you'll find is that surface mount resistors, because of the way the manufacturing works, are very, very, very rarely more than 1% away from the advertised value, even if it's sold as a 5 or 10% precision part. It's rarely an issue for what stuff that we would build, like a transceiver, transmitter, antenna tuner, so on. So I'm going to put this part down, and what we'll find is, see how this part is hanging on there? That's a magnetic result, almost certainly. What it means is that the tweezers are slightly magnetized, not good, but that's what these arrived as. And the part has some magnetic property. The metals that were used to make this resistor in the factory were ferrous. You can buy non-magnetic parts specifically, they get more expensive, or just get a pair of tweezers that turns out not to be magnetic. How do you solve this? Yes. Oh, sorry.
Yeah, another little trick, reason I like that is you also get liquid flux, and that's another thing that can help you is to flux the leads on both sides
Right.
on the circuit board to help you hold it down, and also maybe just enough sticky to defeat the magnetic properties of your tweezers.
So I'm going to actually borrow what you hold the thought. I'm going to borrow what you said. The 6 flux, you'll hear the term flux is not flux capacitor out of what is it, Back to the Future. It is a solvent that typically arrives as a gel or a desiccated liquid that in solder wire is in the core of the solder. So if you look at some of this 32nd inch stuff and you look at over an microscope, like this where it's hollow too, like garden hose, and in the middle is a little bit of this flux chemical. The purpose of flux at a temperature of about 300 degrees Fahrenheit, it will scrub away some of the oxides that build up on copper and improve the adhesion of the tin and lead to the copper itself. And you can get flux separately in a little syringe. And solder paste, which we'll come to someday by about 3 this afternoon or whatever we're going to get there, at the rate I'm going, is basically just little teeny chunks of solder metal suspended in flux. And so your point's exactly well taken. Question, Beth? Sir.
It wasn't so much a question as a comment. I do rework for work. And yeah, I use a syringe. It's actually called steam flux. And specifically to that magnetism. Put just a little dab of sticky flux on, and I can put it on it down. And it can probably.
It's a recommended supply. Go ahead.
And another thing is especially certain sensitive to parasitic resistance on. Another sale point for lead tin is flux can be cleaned with alcohol-based solvents.
Oh, that's a good catch because I didn't capture that anywhere. Buy yourself a bottle of 99% isopropyl alcohol. You can get it online, 5, 10, 15 bucks, depending on the quantity. Do not drink it, not recommend it to gin and tonic. However, if that and some basic cotton swabs, go back to your 2-year-old, clean out your 2-year-old's ears, buy a box of those things at Walmart or something. And it is a great way to scrub the excess flux off. You'll find occasionally reference to a water wash or no clean flux. Some of those are actually have a downside. They have a risk of being somewhat electrically conductive for some sample sensitive circuits. So last call for alcohol. Any other questions?
I was just gonna say, I bought the 90% at Walmart. 90% alcohol. Really.
The balance is just water.
But you're taking a chance on contaminants in it.
Well, I'm using a circuit that just breaks my bikes.
Well, that's fine, but I just electronics, you also have to be careful.
So you're saying that it's really purified if you order it?
Well, and you don't take a chance of getting something in there. And again, I'm just speaking in general. We have a sensitive comparison resistance pass.
Where do you get 99%?
Then
The highest I've found is
You can-
93.
you could be. making
Hold
it
thought.
for yourself.
Okay, so let's just do, I want to just,
Interesting.
you can source the 99%, go online, go on eBay as a starter or Amazon. And just say 99% isopropyl alcohol. It's used in vast quantities in the screen printing business or printed material. They use it for cleaning the old printing plates and stuff. It's a great solvent. You can get it at drugstores occasionally. I've even seen it at Walmart, but the best bet is buy it online. It should cost you about $10 a quart. The quart will last a long time unless you spill it.
Another source is just go to the liquor store and get some great alcohol.
It is.
That's expensive.
But if it's Sunday afternoon and you have got to solder something and you suddenly discover you have no booze in the cabinet. I actually, the grain alcohol is kind of declassed. I would go for the 25-year gallon single. Last question. So, yes, go ahead.
I don't know where all the demos ended up. We didn't get to see any more. I'm kind of curious.
Yeah, sorry, they took a detour back here.
It's kind of.
So we'll let that circulate, and then what we're gonna do here. Okay, so here you are, you're about to build your 1968 vintage Heathkit color TV console. Or you're gonna build a little QRP transceiver or something, and what you've got is you've got a soldering iron preset to about 650 degrees, or crank it about halfway up. You've got your 6337, is that what it is, or 6337 wire solder, comes with flux, that's how it's made. You've got your source of enough light you can see clearly. You've got a mechanism for magnification. So, and you've got tweezers. So 5 things: lighting, magnification, tweezers, soldering iron, and solder. You don't have those 5 things, you can proceed, but it'll be easier if you've got those 5 things. And modern soldering stations can detect when the soldering iron is resting in its little carrier and reduce the heat on the soldering iron tip. Depends on the design. I could go into a whole harangue about soldering iron systems and tips and mechanisms. We don't have time for it.
We'll do that next month.
Okay, so now what you've got here is, look on the screen, and you've got that little part which is sitting obligingly waiting to be soldered. So I need to pick it up again and move it off to the side. So here's where this could be a 3-handed project, but I only have 2-handed. Okay, so what we're going to do, we're going to take the soldering iron, 650 degrees. We're going to take the solder wire, and we're going to place 1 blob of solder, and this is a pitfall. If you do not have sufficient magnification and lighting, you'll tend to put too much solder in place. The #1 pitfall in surface mount soldering is too much solder. Not getting the right temperature is a problem. It's not as severe because of the modern soldering irons. Not enough solder is possible, but too much is the big pitfall. So what we're going to do now is I'm landing the soldering tip, and you notice the tip is fairly small, and we're going to put a little bit of solder there. And if you see that clear stuff going on, that's the flux getting dissolved out of the middle of the solder wire. And you see how it hasn't, and at some point, the solder actually sticks. So that clear stuff is the flux. It is pre-cleaning the oxide from the copper surface. The next thing is the temperature comes up to the point where the solder melts. The temperature of the copper below comes up to the same temperature. And then when the solder is at the right temperature, touching clean copper, which was cleaned by the flux, you create what's called an intermetallic. So, word for those of you who like interesting words. Intermetallic is where a composite of solder and copper bond together. And this is actually a very strong connection now. You can now send this up in orbit and it will survive all the jostling, handling, or you can drop your cell phone, which I do at least once every few days, and the parts will stay adhered. The reason I only put 1 blob of solder on is that I now need to connect one side of this resistor to the little blob of solder. And so now this is why I had to do this in steps, because I only have 2 hands. I'm gonna reheat, or you'll hear the term called reflow. And now I'm gonna move the little resistor onto this. And what I'm trying to do here is I'm gonna tell you a little bit of an anecdote. That resistor, one side of the resistor, likewise got heated, the flux is cleaned up the surface, and when the temperature on the end of the resistor hit this melting point, it also, it's kind of like welding at low temperature. In fact, if you look at the Chinese online sellers, they'll often describe welding and soldering in the same term. You'll also hear the term called brazing. Brazing is typically used for jewelry and some other things at much higher temperatures. So herein, momentary editorial. My lab, I do not use an electronic camera. I do use magnification. What I use is about a $30 kids binocular optical microscope. Bought it on Amazon about 5 years ago. They still sell one. It's a little bit more money. And it's like a miniature, it's like a kid's version of a professional microscope. Things actually work really, really well. What I found is in doing soldering, eye-hand coordination is a really big factor. Here, I'm trying to look at that while I'm maneuvering this part, and the imager is backwards anyway. And my eye-hand coordination is not that great. And I did all I could to get this half of the resistor in place, and I still got a tight one. I tried this at first and quickly gave it up. I went just anyway, this thing's called AMSCOPE, AMSCOPE. You can look it up on Amazon, get the cheapest one you can, which has 2 eyepieces. And what you'll find is it's 2 microscopes, and they're sold to kids, but it's got that sort of stereoscopic 3D perception. And I work with very tiny surface mount parts, just like this, except that I use this stereo microscope.
You say it was AMS?
AMS, like it stands, I think it's short for American Scope. It's an outfit in California. Look up AMSCOPE. I think it's called an SE Sierra Echo 120. I think is their model. It's the low end kids stereo microscope. You don't need much magnification. This has actually got more magnification than we properly need to do this job because we're so zoomed in. But it is a starting point, just something to consider. In any event, what we've got here, the job's half done for the first resistor. Now we're just chattering to death. But the second one's actually easier because the resistor is now packed in place. So I'm now going to heat up the other side of the resistor. And I'm going to put a little teeny bit of solder. The same thing, you'll see that clear stuff is the flux. The board material came to temperature, and the end of the resistor came to temperature, and we now have a functioning solder joint. Now this looks a little bit shadowy because it's called optical dynamic range. The imager here can't distinguish very dim light very well, but this is a viable solder joint. And if I measure with my non-existent voltmeter between this trace and this trace over here, I'll measure 510 ohms, give or take a very tiny amount. That's the first part in constructing an electronic circuit with surface mount. The rest of it is just do the same more. And I think because of the amount of time consuming and where we're already at noon, I'm going to recommend just leave it here. You've seen one. But what I would like to do is, if possible, set up to show reflow soldering with paste. And Larry, you want to take over the?
Oh, no, no, why don't you go ahead and.
So what you're going to do is we're going to have to move the imager or get.
Well, actually, I'll need to get the solder paste on.
Okay, we're going to take one of your patented boards right here.
Actually, why don't we do that board there?
Okay, so this syringe is not heroin. It is almost as good. It is 6337 solder paste. It has a property called microns, which is the diameter of the little individual spheres of solder. It's floating around in the same kind of flux that came in the wire or that you can get separately. This is like a syringe, and I'm going to use a syringe to deposit a little blob of solder paste. Oops, we're going to have to switch over to the imager here.
And that is 5-year-old solder paste that's typically good for only 6 months or so.
I can assure you that 25-year-old Macallan single malt is good after 25 years.
Solder paste has a shelf life?
It
Oh,
does,
yes.
the shelf life is due to the little blobs of solder, the little spheres settling out. It's sort of like if I stir some sand in a cup of water or mud in a cup of water, I've got muddy water, and if I let it sit overnight, what I've got is clear water and mud at the bottom. The same process happens, and so commercially, this consistency of the solder paste becomes a concern. The actual amount of separation is not that severe, and for a hobbyist use, you'll never detect the difference because you're working in hand soldering. So don't be concerned if you've got something at the end of its service life.
And you wanna keep it in the refrigerator.
But when you take it out of the refrigerator, let it come to room temperature before you store it.
Yes.
It gets real
Oh
thick.
my gosh.
So what we're doing now is
Details are amazing here.
we're now going to apply a little blob, and you can see where the eye-hand coordination is just a pain in the butt.
And you can tell how old the solder is because it doesn't wanna flow.
But you can see sort of now, this is, I've created two little islands of solder. You'd think this is very ugly, but in actual fact, look up the term surface tension. When I heat this up to a melting point, the solder paste, it's the little blob spheres suspended in flux, will join together to make one blob of solder, and it's called surface tension. It will pull the little tendrils of, it'll make it ugly and pretty is what it amounts to. So I'm gonna take another resistor, and I'm gonna put the resistor here temporarily because it's something I want to show you. Let's leave it right there. No, come on.
Upside down.
I want it upside down for a reason. That's what the bottom side of the resistor looks like, because the thing is made of a teeny bit of ceramic with a very thin coat of semi-conductive metal film is what they call it. If there's no sin in putting the part on upside down until you decide you want to go fix it after 15 years because you forgot what the hell you built. So I recommend.
So the film is insulated on the top that they put on it, so if you mount it upside down, it's not a problem.
Yes, yeah, the only conductive area is the the silvery ends in this case. The top side is the lacquered paint with the numbers printed on it. The bottom side is unlacquered ceramic, same stuff. The by the way, this part is 1/8 of an inch long. There is a package size criteria. This is called a 1206. Remember the Mills business? The industrial people love to use thousandths of an inch, even if you're in Asia somewhere. This is a non-metric measure, which is most common. This part being 1/8 of an inch long by 1/16 of an inch wide is considered a very large surface mount part. It's nice for hand, but it makes a physically large part. And if you go to Corey just beamed out, on his radio, most of those parts are called an 0603. It means it's 1/16 of an inch wide, 1/16 of an inch long, 1/32 of an inch wide. Hence why you need very fine tip tweezers. So what we're going to do now is we're going to take this part and we're going to plop it down roughly in position. This is by hand. You said, how do the parts get on the board? This is by hand how the part got on the board. But what we looked at on the slide deck showed a machine who's doing that in a mechanized way. Therefore, the machine is encoded not only with what the required part is, but also where the part goes on the board. There's another data file other than a Gerber file that guides that process. And so now we're now going to apply some. You need to get the tape off there if you want. Otherwise, we're good.
That's what I was looking for here.
And so, what Larry is doing now is removing the Scotch tape, getting the board freed up. This part will stay in position pretty well because the solder paste is fairly thick. It's like half cured paint for painting your house. So the part won't move around much in handling. And now what we've got is.
Thanks. If you've never done SMT soldering before, that's like a jump for your practice and patience. Because the other thing is that you can see his hands Well, but it's under magnification. And how you move when you brace yourself, when you're doing those things, it's very tricky. And also, as you said, to translate a movement under the microscope with my hand. It can be really frustrating.
And I undock this camera.
You can try to get some more. Either saw circuit board, SMT mounts.
And by the way, this is heated, so this may or may not, it won't cause damage, but it's gonna be, can you flip over to the image so I can see?
Didn't you surgery think it's only a
Well-
few $1,000,000?
Oh, okay, so, okay, now,
morning you don't drink.
okay, here is.
Oh, it was, yeah.
Okay, so, need to draw attention, because this is a hot plate that's been preheated. It's hot, so we have to move quickly. Okay, so can I get 100% undivided focus for about 30 seconds?
Yeah.
Okay, so here we are, and now Larry's going to take the circuit board and put it on the hot plate.
If I can grab it with the
And,
long nose here.
and we're gonna put it out towards the edge of the perimeter, because I don't want to get the camera too close.
Yep.
So now we're looking live at this surface. This thing's gonna be heating up. You can see the movement. And you can see, if you look carefully, you can see the little teeny spheres of solder in the paste. We're waiting for that to go from a gray blobby stuff to a silver metal. You can see it's spreading out, it's heating up. And at some point momentarily, you can still see the individual spheres of solder, which are 3 microns diameter. And we're waiting for those solders to melt. It's taking a little while because the temperature of the board is being heated from the hot plate. And the hot plate's set to a temperature that is probably just moderately close to solder point.
Yeah, actually 350 degrees. And if your wife doesn't mind, you can use a pancake griddle, or you can use a rubber fry pan, or
Okay.
heat up a block of metal.
Look closely now, you can see it's gone from spheres to sort of a gray. It's approaching the melt point. This is happening slower than it would happen in real life, but it's very
There we
quick.
go.
This is live and in color. And so we're letting the other side go through its transition.
Wow.
And the solder,
Wow.
the solder is coalescing and using surface tension. There might be a short under the part. Nope, probably not.
Nope, because the depth of the cut, and also it doesn't stick to the fiberglass.
Okay, now, what the other thing is, see the part below it? That solder that I applied by hand is also in the beginning process of melting, and you'll hear the term called reflow, R-E-F-L-O-W. That is what meant we're just heating the solder up to a melting point. So we're gonna now take the part off. This survived its lunar reentry process. And now I'm gonna turn the hot plate back off so we don't fry anything. And what we have here is our assembled by hand soldering, assembled by, come look at it if you like. And thus is the demo.
Yeah.
Okay, so now I'm gonna get the B104 back to its rightful owner.
And the fun part is, if you have a professionally made circuit board, you don't even have to get that part on straight. Basically what happens is that it straightens itself out. Essentially, the surface tension pulls it right where it belongs. At least that's been my experience.
So you're seeing this like, I've never done this before with the hot air or with the plate, except as a preheat. So if I'm a beginner at that, it's doable. A little practice, it gets better.
So anyways, that is a quickie demonstration of working with a surface mount. And really, it's not that hard. And, the good old days were not the good old days.
As my former next door neighbor said, these are the good old days. He was not an optimist.
Exactly. So anyways, I don't have anything else here.
We had a couple of folks that wanted to say just a little, couple things, so.
Oh, here.
Yeah, sure.
So.
But I never.
Can you hear me okay, everybody?
Never solved any problem.
Can you hear Jim? Can you hear me? Let's show, can we show this? Sure.
If that pig flavor ever dies.
Oh, did you go away?
No, what are you trying to
Show
do?
that on the screen.
Oh.
That will be important for this. But what I'm gonna tell you is cutting edge technology. In our Indian Peaks Radio Club, one of the people is doing research at the university, the Colorado School of Mines. They are producing amplifiers in the good enough for production. This is 150 gigahertz, not megahertz, gigahertz, 150 gigahertz amplifiers that they're using for future use, like in satellite stuff. Now, are you showing this? Okay, you see these traces here? There are waveguides. These traces are in the micrometer distance. And this is actually used as a waveguide. Can you move it down a little, this little, so you can show the, okay, stop. The waveguides, this and this would be grounds. This would be the center. You think of a waveguide, but it's just as on the circuit surface. And as long as the depth of the thickness of these boards is like a wavelength, and you can measure 150 gigahertz, that doesn't have to be if you look at the patterns of electrical patterns, it just goes, above and below the board, but it's restricted. And the waveguide is just these 3 parallel lines. And they're producing and doing work to show that they can produce these at scale commercially available, applicable, that are reliable, which is really, to me, amazing. But it goes right along with this talk today.
Yeah, very cool. Thank you.